Well, hello there, Algebra 1 students. This is Big Ideas 3.1. We're looking at functions in this lesson. So we're going to identify what a function is, and that's a big part of algebra, is understanding what functions are. Because at this point, then we go on to looking into, even as we go into rest of Algebra 1 and even Algebra 2, we look at all different types of functions. But we need to understand just what a function actually is from the get-go. So we're going to be looking at determining whether relations are functions, finding domain and range of a function, and also identifying the independent and dependent variables of a function. So those are a few things that we're going to be doing in this lesson. All right, let's take a look at a cartoon. Start us off here. Looks like this guy has the dog driving the car. He says, "Hey, I'm not crazy. Sure, I let him drive once in a while, but he's never off this leash, even for a second." Thinks as long as he has him on a leash, he can go ahead and drive his car. All right, let's go ahead and jump into our function lesson now. Okay, we're going to start with some vocabulary that's right there in your journal books. You have relation and function. Those are the first two that we're going to look at. So just what is a relation? You can write down that relations, what they do, they pair inputs with outputs. They pair inputs with outputs. So basically, if you think of an input and output, what that is, now we've done already, looked at coordinate planes a little bit. So that should have been a bit of a pre-algebra for you with coordinate planes. And what you're seeing down here, it says determine whether each relation, so each of these are a relation. They have inputs and outputs. You can see them in different formats, but the simplest way to think about it is that it's a set of ordered pairs. So you have a bunch of ordered pairs. That makes a relation. So a relation is any set of ordered pairs. You go ahead and write that down as far as what a relation is as well. You can say a set of ordered pairs. Okay, and now I need to look at what is a function, because now it's saying determine whether each relation is a function. So what a function is, if a relation pairs inputs with outputs, that means x's and y's, pairs them to make the ordered pair. A function here is a relation, so it is a relation, that pairs each input with exactly one output. So write that down for where it says function on your notes in the vocabulary, but there's also another simpler way I want you to also write it as well. Another way we can write it and understand it is basically this. What this is basically saying, where it's saying each input, which is the x, is paired with exactly one output. That basically is saying that all the x coordinates, I'm going to go and write this as well, all x coordinates in your ordered pairs are different numbers. They're all different numbers. So basically, as we look through these A through D, we can see which ones are going to be a function. They're all relations because they're all sets of ordered pairs. They're pairing inputs and outputs, making ordered pairs. But let's say look at A. Are all the x coordinates different numbers? This is numbers over here. So we see x coordinates -2, -1, 0, 1, and 2. They're all different numbers, so we can say for this one that this one here, letter A here, is a function. So we're going to say, determine which ones are a function. Well, this one is right here. A is. That sure is. That's a function. So A is a function. Look at B. So 4, 8, 6, 4 again. So because we got 4 twice, they're not all different numbers, the x coordinates. So this would be no. B would be no, not a function. So this one is yes, A is a function. Look at C. Look at all the inputs. The inputs are all up on top here. So we have -2, -1. There's 2 zeros right there. So just for fact right there, 0 is there twice. Zeros with 5, zeros with 6. That's also no. C is no. That is not a function. It's a relation, but it's not a function. And then for D, down here, this is a different way. Every arrow is an ordered pair. So you have -1, 4, 315, and 1115. So every input goes to exactly one output. All the x numbers of those ordered pairs would all be different. So yes, we can say here, yes, D is a function. Okay, now look at your extra practice just on like the next page or two. Number 1 and 2 on extra practice. I think this is on page like 62 of your notes. And go ahead and pause the video and answer number 1 and 2. Determine whether these relations are a function. Pause it and then check your answer. Okay, hopefully you got answers now for 1 and 2. So number 1, is this relation a function? The answer should have been not a function. No, it's not a function. The reason why is because the x-coordinates right there, -2 and -2, they're the same numbers. So right there, not a function. All the x's have to be different. Every input has to be paired with exactly one output. So you can't have two inputs pairing with different outputs. Number 2, this one you can say yes, it is a function, because if you look at all the x's, 0, 1, 2, and 3, they're all different numbers. So yes, that was a function there. Alright, let's move on. Now this core concept is also in your notes. You can see it there. It's called the vertical line test. So if we're given a graph, that's another way we can identify a relation and a function. All graphs are relations, but not all graphs are functions. So in order for a graph to be a function, we can use this vertical line test, like this dashed line going down here. If you take a dashed line, you kind of go across the graph with a straight vertical line. If you touch that anywhere on the function, so let's just say I'm going to go and get a vertical line here for myself. I'll just make one here. Let's see if I can. I'm not going to do it on that though, but let's see if I'll do it in red. Yeah, there we go. Oops, where'd it go? Lost it. I'll have to make it again. It's there, but I'm not going to be able to grab it. That's good enough there. Okay, now I can grab it. Come on. There we go. Yeah, no, it's not going inside that. I was hoping it was going to go inside that. But basically, you can sweep it across the graph. You can take any kind of vertical line, sweep it across the graph. You can see that right there. It's only going to hit each point one at a time there. That's what the dashed line is kind of showing. That dashed line in there is showing that. So that one's a function. It's only going to do that, only hit one point at a time. But when it does it to this, kind of sideways U shape, it's hitting two places, here and here. As soon as you enter into this, you're going to be hitting two places. Even the y-axis is a vertical line. You're hitting those two places on it. So let's say, look at these two graphs. Determine whether these graphs are functions. So if we had a vertical line going right through, we can see right at 2, we're going to hit those 2 points at the same time. So just that very fact, no, this is not a function. So this one's no, it's not a function on this one. Letter B, now you don't need to copy these down, by the way. Don't just do the ones that are in the book. So I don't expect you to write these down. You're just kind of watching and getting an idea here. On B, if I had a vertical line going through this, I'm only going to hit one point at a time on this line. So this one is, yes, it's a function. So we could say yes, so the graph represents a function. Yes, this is a function, but this one is not. It would hit 2 points there. It would also hit 2 points on that spot as well. All right, so come on, try. Okay, so again, go ahead and pause the video and do 3 and 4 on that extra practice. Now use the vertical line test to determine if these are functions here, and then play it and just check your answers. Okay, so you should have got an answer for each one of these. And for number 3, you should have said that it's not a function, because you can see it right there. Those two, you're going to take a vertical line and it's going to hit 2 points at the same time. So that's not a function. That's like, nope, doesn't work. Number 4, however, is a function. You could say, yes, this is a function. This shape, when it's going like this, vertical line coming across here, you're only going to hit 1 point at a time as it kind of goes down the U and back up the U. So yes, that's a function there on that one. Okay, so we're going to go back to page 59 in your notes. That is the exploration page. exploration 2, I believe. And I don't usually do explorations in these videos, but I just thought it'd be good extra practice here to do these. I liked these ones. So I'm going to have you do these on your own, and then I'll again show you the answers of these. So letter A and B, go ahead and just do letter A and B. Determine whether these relations here are functions. So go ahead and pause the video and get an answer for A and B. Alright, so letter A, answer for that one you should have got, hopefully. Oops, I did B first, sorry. Okay, we'll do B. So letter B is not a function, and you can see it's not a function because all the x's are the same number. So even just if we had two of them that were 8, it wouldn't have been a function. Letter A is a function because all the x's are different numbers. It's okay that the y's are all the same. X's just have to all be different. So 0 through 4, they're all different. So those are a function. Okay, let's go on to C next. Okay, so try C and D now, and again, pause the video, get an answer for C and D, determine whether these relations are functions, and then play it and see if you're correct. Okay, so for C, we have the inputs in this kind of little bubble, the outputs are in this bubble, and each arrow is an ordered pair. So it might be helpful to write down each ordered pair. So the top arrow is going to be the ordered pair 1, 8. Then you got another one with 2, 9. 3 actually has here 2 ordered pairs because it's got 2 arrows. So you got a 3, 10 and a 3, 11. So now you can definitely see, well, x is the same on both of these ordered pairs. So no, that one's not a function. Hopefully you got that one right. So you see x, the number x on this one, the input is paired with 2 outputs. And you can only pair each input with only one output. Letter D, you should on this one hopefully got that it is not a function. Using that vertical line test, you would go through, okay, I'm going to hit this one by itself, 1 there, 1 there, 1 there, but when I get to this spot right here at 5, you end up hitting those two at the same time. So right there, it's not a function. You should have definitely seen it as well here. Well, it only needs one of them, but we actually have 2 places where you're hitting it 2 points at one time. So again, not a function because of it not passing the vertical line test. Okay, so now E through J, right there, I'm going to have you try these as well. So go ahead and do E through J, same thing, determine if each relation is a function. We haven't really looked at these, but try these from G through J as well. Go ahead and pause the video, complete E through J, do your best, and then play it just to see what those answers are. Okay, hopefully you got some answers here from E through J. So E, we know about this one. And if you just look at all the x coordinates, they are all different numbers. So you said, yes, that's a function right there. On F, on this one, you can look and see, are they different numbers here? And they're not all different numbers, no. So that's not a function, and you can see the ones right there. You have 2 negative 1s there. You have x is a negative 1 in 2 places. This one's a little different. It kind of gives you a situation. Each radio frequency, X, in a listening area has exactly one radio station Y. So each X is paired with one Y, so that's our definition of a function, yes. The H says the same television station X can be found on more than one channel Y. So X is going to be paired with more than one Y. That's not a function, no. So that we can't do that one. That means X is going to be there twice. This one where it's giving you some equations here, X is equal to 2. Actually, this looks like the answer to an equation that we may solve at some point, but this is actually referring to a graph. This one is not a function, and the reason why it's not a function is because it's a graph like this. On a coordinate plane, it's a straight line going through 2. And you'll get to know these. We'll get to learn these as well. So it's a straight line through 2, and that's a vertical line itself. So these are vertical lines when it says x equals a number. And so obviously a vertical line is going to fail the vertical line test. It's going to touch more places than 1. This one, however, y equals 2x plus 3, that one is a function because it's more of a diagonal line. It looks like this. And we'll get to learning how to graph these lines as well in chapters to come, or sections to come. So there you go. That's a function as well because it does pass the vertical line test. Alright, so here's our joke of the day. We're going to do a quick break for our joke of the day. Which school supply is king of the classroom? Which school supply is king of the classroom? Is it the eraser? Is it the piece of paper? Is it the marker? Which supply is it? It's the ruler, of course. The ruler is the king of the classroom. All right. All right, so let's go ahead and look now at what is domain and range are of a function. So you have this core concept. It's kind of a weird looking maybe machine here. And so we have this machine is just showing us a kind of a picture of a function. You put something in the machine, it does some kind of working out here. You calculate it, does a kind of operation, right? Like multiplication, division, adding, subtracting. It does the operations, and then it spits out the answer over here. The output is the answer that you would get. Now the input is always your x number. You'd put that into the function, like right there, y equals 3x. And so if I put in a -2 right here, 3 times -2, that's the operation. I'm doing multiplication as the operation. It spits out the answer of -6. That's the y answer. The output is the y. So basically what a domain and range are of a function really kind of happens when you look at the whole entire function on a graph. So the domain, and you're going to want to write this down in your notes as well for the vocabulary, the domain of a function is the set of all possible input values. So remember the input values, those are the x coordinates. So all of the possible input values. So, on a function, if you just it could be a function that just continues forever and it goes everywhere. All possible values are everything. So it's possible that everything is a domain as well, or it could be just limited to a certain amount of numbers. So the question really to ask yourself, however, is this question. So go and write this down also for domain. Is where is the graph on the x-axis? That's what you want to ask yourself, especially when you're looking at a graph, is to find the domain. And typically we're going to be asking the question about domain and range when we're looking at a graph of a function. The range is basically everything the same here. So the range of a function is the set of all possible output values. That just means it's the y-coordinates, the output values. And so over here you're asking yourself the question, especially with the graph, where is the graph on the y-axis? You just need to remember that domain is always about the x-coordinates, where it is on the x-axis, and the range is all about the y-coordinates, the y-axis. So again, input, output, and domain and range. So I kind of always remember that kind of as alphabetical order. So if you were to even look at like even ordered pairs, x then y. X comes before y in the alphabet. Input is about x, output's y, so I comes before O in the alphabet. Even domain and range. Domain is going to go with x, range is with y, and so D comes before R in the alphabet. So that's how I've always remembered this. Just alphabetically, domain is first and x is first in our ordered pairs. So domain is always going to be the x coordinates or where it is on the x-axis. Let's go ahead and try a couple now. Alright, here's two that you don't need to write down. Just go ahead and watch this to kind of get the idea. It says find the domain and the range of the function, and notice it is graphed. So we're looking at graphs here. That's why I say you want to ask yourself the question, where is it on the x-axis, where is it on the y-axis? So basically, where is the graph here on the x-axis? Well, it's every one of these dots here is an ordered pair, but it coincides with an x-coordinate. Like this one's going to coincide right here with -3. This one's at -1. This one is at +1 for x. This one is at +4 for x. That would be our domain. The range, where is it going to coincide with the y-coordinates of each of these ordered pairs? -2. This is to be at 0. This one's at +2. And one's at 4. So that's where you can see there. There they are. The inputs, if you listed all the ordered pairs, all the inputs would be your domain. So the domain is all these numbers, -3, -1, 1, and 3. And the range is all the output numbers. There it is, -2, 0, 2, and 4. That's all the possible inputs and all the possible outputs of this function because it's only just a set of ordered pairs here, just some dots on the graph. This one's a little different because it's not just some dots on a graph. It's got 2 dots, but then it's got this, whole thing connecting these dots as well. So this is a little bit different. In this case, we're going to have to see that where is this on, that's why I like to ask that question, where is it on the x-axis? Well, it's starting here at -3 and it continues until +3. That's where we find it on the x-axis. All of these numbers from -3 to +3 are your domain because that's where they all are. So like even a point right here would be at this point here on x. Point here would be at this point on x as well, and so on. The range would be starting here down below, it's starting at -1, and it continues all the way up until we get to +2. So look at what it's going to look like here. So you got your domain, okay, like I said, from -3 to 3, and your range here is from -1 up to 2. So look at how they're going to do this. They're going to do it with an inequality. This is the compound inequalities that we've learned before. So we just learned how to do these compound inequalities back in chapter 2. It's where you put x in between those numbers, right? So -2 to 3. So it's from -2 to 3. X is in between there. Y is in between -1, 2. All right, so that's what we do when it's kind of continuously like that, when it's continuing from one point to the next. Okay, so for 5 and 6, let's do these together to find the domain and the range of the functions of these graphs here. So it does say it's a function, so we definitely know. We're not asked whether it's a function. They tell us it is a function, but we're trying to find the domain and the range of the function, so we're trying to figure out all the possible x coordinates, all the possible y coordinates. And sometimes it might be a continuous one like 6 where we got to use the inequality to describe that. So with number 5 here, these are just ordered pairs, 6 different ordered pairs. So for x, the domain, remember, is the x coordinate. So for x, where are they at? So we got 1 at 0, so we can say, okay, 1's at 0, next one's at 1, the next one's at 2, then this one's at 3, this one's at 4, and that one's at 5. So those numbers right there are the domain. We just listed all of the x coordinates of these ordered pairs. Now, what about the y coordinates? So the y coordinates actually are the same for 3 of them. These first 3 right here all have the same y coordinate of 4, and these all have the same y coordinate of 3. So we don't need to say 3, 3, 3, 4, 4, 4. Instead, what we're just going to do is we're just going to say 3 once and 4 once. The range is just 3 and 4. So the range, that's all it is. Those are the possible output values, just a 3 and a 4. If we were to do that kind of bubble thing where we would see, taking the arrows, we can say arrow, these 3 would all go to 3 here, these would all go to 4, and so on. Okay, for number 6, we're looking for the domain first. So our domain is going to be between, right there, -3 and +3, because there's our points. So right here, the first one starts at -3, and the second one here ends at +3, and it continues between those two numbers. So what we're going to do is write our inequality out with x in the middle between those two numbers. So x right there is in between -3, +3. Now you always have to put less than or equal to symbols here. For one, it's equal to that because it's not open holes. Those are closed holes there, so that's why we definitely do the equal to. It's less than because you're starting with the smaller number, ending with the bigger number. So if you put the greater than symbols, then that would not work out. That wouldn't be correct. So you always make sure your less than symbols are there. Now for the range, let's look at where the range is at. It's right there between, right here it starts, the smallest number it starts at is 0, and it ends right here at this one at +3. So y is going to be between 0 and a +3. So that's what we're seeing there. Again, less than or equal to symbols. So 0 is less than or equal to y, less than or equal to 3. So 0 is in between 0 and 3. Okay, so now we come to kind of our last part of what we're learning today, just identifying independent and dependent variables. It's not really much anything different. We're still going to go off of just the inputs and the outputs. The independent variable, so there in your vocabulary, what do you want to write down for independent variable? The main thing you want to say is that they are the input values right there. The independent variable are the input values. So you can see right down here, it's the x coordinates. And so you can also say that independent values are the x. That's what you want to see. The input values are going to be the x going in. For dependent variable, what you want to put there is that they are the output values. Maybe I'll do that a different color there. The output values. So output values is the dependent variable. As you can see, that's the y-coordinate. Outputs are the y-coordinates. So the x is going to go in. So like if you're going to put something into the function, that's going to be the x. That's what it says here basically. So it says that they are the independent variables, the input values, because it can be any value in the domain. So this right here, you can pick any number you want to plug in for x. We can pick -2. Okay, we plug that in, we got -6. We can pick any number we want to here for x to plug in. We can pick 0, we can pick a fraction, we can pick a decimal, it doesn't matter. We can pick a positive number, a negative number, it doesn't matter. We basically get to choose the inputs to plug into the function, to stick into this function. The dependent variable are the output values because it depends on the variable it depends on the value of the independent variable. So the number that you get here, -6, is always dependent on what you put in. So if I put in a different number, I'm going to get a different output. So that's why this is always our y-coordinate. The dependent is always the y-coordinate because it depends on what you put in to the function. So just remember, that's another way to identify, again, just x and y. X is the independent variable, y is the dependent variable. So it even shows you an equation right here showing y is the dependent variable and x is the independent variable. I could plug numbers in here for x, like if I put in 0 here for x, then our y is going to be 10. But if I plug in 1, then the y will be 9. So the y always depends on what we plug in for x. Okay, so here our last problem, number 7 on our extra practice. There in our notes, let's go ahead and do this one. This is talking about independent and dependent variables now. So the function y equals 12x, that's 12 times x, represents the number y of pages of text a computer printer can print in x minutes. Okay, so it gives us, here's the equation, but it actually gives us what the x and the y represent. So it says identify the independent and dependent variables. So that's typically when they're going to want us to identify independent and dependent variables when we're given a situation of what x and y actually do represent. So they're going to have to tell us some information like they're doing here. So the independent one is the x, the dependent one is the y. So for x, you can see right here, x minutes. So x is the minutes, then that's identifying, okay, so identify the independent variable, that's minutes. How many minutes it's going to take to do the printing. And then the dependent variable, it says it right here, y, number of pages. So right there, pages, the number of pages is y. So the dependent variable is the pages that you would print, the number of pages, and then minutes, how many minutes is the independent. So if you say, okay, plug in minutes to this, we say, okay, this many minutes, it's going to multiply it by 12. So if we say 1 minute, it's going to be able to print in 1 minute, it's going to be able to print 12 pages. That's how many pages it'll print. In 2 minutes, it'll print 24 pages, and so on. Okay, B says the domain is this, these numbers here, what's the range? So that's what we're going to kind of do now. We're going to use this equation, y equals 12x, plug in these numbers for x, these are the domain numbers, all the possible inputs, so we're going to put those in, and then find the range. So the first one is 1, so we're going to plug in 12 times 1. We just said that's 12. And we plug in 12 times 2. We did that one too. That's 24. 12 times 3, that's going to give us 36. And then 12 times 4 will give us 48. So our range are the 4 numbers right here of 12, 24, 36, and 48. Alright, so almost done. We're going to do actually a little quiz here at the end. I don't typically do this too often, but I wanted to do this one here to give you some extra practice on identifying functions and domain and range. So we're going to go to page 61 there in your notes. There's a little bit of notes at the very bottom of the page. It says notes. So just right there, go ahead and number 1 through 10. Actually, we're going to do 10 problems here. 1 through 10, and you're just going to answer them there. Just put the answers down. You don't need to write the problems. The problems are here. Just go ahead and answer the problem, or answer them, and then I'll show you the answers here in a second. So let's do 1 through 4 first. So determine whether the relation is a function. Go ahead and do 1 through 4, and then I'll go ahead and show you the answer there. So pause the video, answer 1 through 4 on page 61, and then I'll show you the answers. Okay, so hopefully you got the answers for 1 through 4. So here we go. Number 1, the answer should have been not a function. It wasn't a function. You should have noticed there's a 5, there's a 5. Yep, not a function. Number 2, it is a function. Yes, it's a function because they're all exactly different numbers for x. Input has exactly one output. That's the definition of the function. Number 3, this one is a function. Yes, because all these inputs here are different. Again, every input has exactly one output. Number 4, this one you should have said not a function because there's only one input and that input has 3 outputs. So the input 1/2 has 3 outputs. So that's not a function. Alright, let's try next set of problems here. So we're going to go to 10. So let's try these. So 5 through 8, determine whether the graph represents a function. So use your vertical line test to say yes or no on this one. Is this a function or not? Go ahead and pause the video and do 5 through 8. Okay, hopefully you have answers now for 5 through 8. Let's go ahead and check these. Number 5, using the vertical line test on here, it is a function. It passes the vertical line test. It's only hitting one dot at a time as you go across this with a vertical line, like your pencil or your pen. Number 6, yes, this one also is a function. It passes the vertical line test. As you kind of go down the U and back up the U, you're only touching one point at a time. Number 7, the circle. No, that's not a function because as soon as you go in, you're going to hit 2 points at a time. As soon as you're inside the circle with a vertical line, you're going to hit 2 points at a time. And number 8, we have a V shape on this one, and that is, yes, it is a function because as you go down the V and back up the V here, you're only going to be hitting 1 point at a time with a vertical line as you do that. Alright, just our last two, 9 and 10. Let's do 9 and 10, then we'll be done. 9 and 10 ask you to find the domain and the range of this function. So this one is just the points. So they're just going to be numbers only. This one's going to be inequalities, those compound inequalities. So go ahead and pause the video and write down what the domain and the range are for 9 and 10, and then play it to check your answers. Alright, so you're going to check your answer for number 9 first. You just should have had all the x coordinates there. So the domain was just 5 numbers, -2, -1, 0, 1, and 2. The range is only 3 numbers there because these two have the same y number, y coordinate. These two have the same y coordinate as well. So you have a 0, you have a 2, and you have a 4. So there's actually only 3. If you put 0, 2, 2, 2 2s and 2 4s, that's okay. I would be okay with that, but just know you don't need to do that. Number 10, this one might have been the more challenging one. So our domain here is going to be from 1 to 5 on the x-axis. So this point would be from 1, continues all the way over here till 5. So x is in between those, and make sure you have the equality signs facing the right direction, less than symbols. And the range is going to be from 0 to 4. Starts here on the x-axis, goes all the way up to 4. So from 0 to 4 on the x-axis. Again, that's why you're asking yourself that question. Where is the graph on the x-axis for domain? Where it is on the y-axis for the range? And you can see it's everything in between 0 and 4 on the y-axis for that range. Alright, so that concludes our lesson here for functions. I'll see you on the next one for 3-2. Have a great day.